Hello students, today we are discussing class 7 physics chapter 2 motion and part 6 in which we are going to discuss about mass and weight. So mass as defined, it is the amount of matter contained in a body. So now the properties of mass are that first of all it is a constant quantity, that means it does not change. That means whether I place it on my hand or whether I place it on the table or whether I place it anywhere, it is a constant quantity. Let's say the mass of this particular duster is, let's say, 50 grams. So no matter where I take it in the whole world, it will remain 50 grams. Whether I take it to space also, it will still weigh 50 grams. It does not change with place or direction. So which means that like whether I throw it somewhere or whether I place it somewhere, anywhere in the world or even in space also, this is not going to change. The mass will remain the same. So for measurement, the SI unit of mass is kilogram, and this is denoted by kg, which is small k and small g. If you want to measure smaller quantities of mass, we will use the submultiple units, which is gram, which is denoted by small g, and even smaller than that we will use milligram, and it is denoted by small m small g, mg. To measure mass, we have devices, and one of the devices is called a beam balance. A beam balance is a common balance which you normally see shopkeepers using to measure weight of vegetables. So it is a very simple device in which it has got a beam which could be made of wood or rod, and it is suspended by its middle point in such a way that it balances, and on the two ends of it there is either a chain or a string, and which is connected to pans, which is used for holding the item that is being weighed. So this is called a beam balance, and this is used for measuring mass. So how this is used is, on the one side we put a standard weight which is known, let's say for example 1 kg weight on the one side. So this will cause the one side of the pan to be heavy and come down and disbalance it, and whatever you are trying to weigh we put on the other side till such time the beam is horizontal. So there's a needle on the top of this beam over here, which when it points exactly vertically, so that indicates that the beam is horizontal and it is balanced and it is in equilibrium. That means the weight on the left side and the weight on the right side is equal. So this is the way a physical balance, a beam balance is used to measure mass. So if you put 1 kg mass on the left side, obviously when you balance it, whatever item you are weighing, that will also be of a mass of 1 kg. The second one is a physical balance. A physical balance is normally kept in a glass box, and it is normally used in a laboratory. And the reason why it is placed in a glass box is because it is a very high precision instrument. Okay. And it is of a similar structure, that is of a beam balance. It's got a pan, it's got a beam, and it has got a pointer here, and it can be used to measure very minute quantities of mass. So since you need to measure very light quantities, so this can be used. And the reason why it is enclosed in a glass box is so that it doesn't get disturbed by movement of air, which will maybe cause inaccuracies in the measurement of mass. So physical balance is used in laboratories for measuring mass in very small quantities and very accurately. So the next type of device for measuring mass is called an electronic machine. Nowadays you get, in which there's a panel in the front, okay, and there's a space on top where you keep the item that is being weighed on top, and there's a LCD indicator in the front which will give you the reading directly as to what is the mass of this object. So you place the object on top on the top where the pan is, and you will get the reading directly out on the LCD display, which will tell you exactly what is the mass of the object. So with regards to this, we are done. Next, let us discuss about weight. Weight, as per definition, is it is the force with which a body is attracted towards the center of the earth. So by definition, weight depends on the force of gravity of the earth, and weight is basically the force with which the body is attracted towards the center of the earth. So let's say this is the center of the earth, and let's say this is the object. The object is getting pulled by the gravity, and that direction is towards the center of the earth. So the force by which this body is getting attracted by the earth, that is called the weight. Now the SI unit for measurement of weight is called kilogram force. The SI unit of weight is measured in Newton, and when you write the full word Newton, it is in small case, whereas if you write in a single alphabet, it is always written in capital N. So Newton is the SI unit of weight, and it is also expressed in another unit which is called kilogram force, okay, and that is denoted by small kgf. And for smaller units, we can use the unit gram force, FRCE, and we can use the units, we can denote it by GF. Now 1 kilogram force is the unit in which the earth attracts a body of 1 kg weight. Let's say you got 1 kg weight here. The force with which the earth attracts this body, okay, that is called 1 kilogram force by simple definition. So in the same way, what is 1 gram force? In the same way, let's say if you got a body of 1 gram and that is being attracted by the earth, and the force by which this 1 gram body, this body of 1 gram is being attracted, that force is called 1 gram force. Now the relationship between 1 kilogram force in Newton is 1 kgf is 1 kilogram force is approximately exactly 9.8 newtons, and normally we'll take it as 10 newtons. So this is something that you need to remember whenever you need to convert a kilogram force into newtons. So 1 kgf is equal to 9.8 newtons. Approximately we can round that off to 10 newtons. Next, we have devices to measure weight, and that device is called spring balance. So the construction of spring balance is very simple. It basically consists of a spring, okay, and at the end of it there's a hook for which where you can hang the weight of the body that you're trying to measure, and this is enclosed in a box in which there's a slit through which we can see a pointer attached, and there's a graduation marking here. So this, as you apply the weight, this pointer can move up and down depending on the weight by which the spring is getting pulled, and this pointer will point directly to the weight. Let's say for example it is pointing to 10 GF, so that means this object which you're trying to weigh, the spring balance is indicating that the weight of this object is 10 GF. So the spring will stretch if you apply more weight, and if you reduce the weight, the string will get compressed and the pointer will move up and down accordingly and tell you exactly what the weight is. Now let us understand the difference between mass and weight. So let's say we make a table to compare. First of all, by definition, mass is, okay, let me write short form. It is the amount of matter in a body, whereas in the case of weight, it is the force by which it is a body, or rather a body is attracted to the center of the earth. So this is the first difference. Mass is the amount of matter contained in a body by definition, and weight is the force by which the body is attracted to the center of the earth. Mass, as we learned in the definition, is constant and it does not depend on the position or the place where the body is placed, whereas the weight, it changes. It changes as it depends on the gravity of earth. That means a body which is on the surface of the earth has a certain weight. Now if the body goes higher and higher into the sky, the gravitational force becomes less and less, the weight of the body becomes less and less, and as you enter space where there is no gravity, the body becomes weightless. So mass of a body never becomes zero. So mass can never become zero, whereas in the case of weight can become zero. Now where does the weight become zero? Weight becomes zero in space because there is no force of gravity attracting it, so weight can become zero despite the fact that mass cannot become zero. And I'm sure you must have seen certain videos or movies where in the space you find that people and objects are floating about. It is because there is no gravity in space, so that's why objects become weightless and they float around. Thank you.